If you're uncomfortable, you can go, but otherwise, it's good to have you. Thank you. Yeah. All right, so let's get back to where we are. I want to talk about this example we started out with. So we got a directory we're going to explore and find out how many files there are in this directory. And in this case, we are looking at /applications directory. We just took an arbitrary directory to look into. And we're going to tell how many files there are in this directory, and we're going to say how much time it takes. Now let's, while it's doing that, let's talk about how would we make this concurrent. The way I'm going to make this concurrent is, I'm going to first take one actor, and I'm going to tell this actor, go explore and find out how many files are in this directory. And the actor says, all right, but I'm not going to do any real work. I'm going to just give this to a slave actor and say, hey, you slave actor, go find out how many files are there and let me know. And notice that it took about 97 seconds. Keep in mind about 100 seconds, right? That's easier to remember. So it took about 100 seconds to do this. So we'll come back to looking at this a little bit later. So let's comment that out. I don't want to be running that and waste time again. So we're going to create an actor. And the slave actor says, OK, I'm going to go find out from the slave actor. And the slave says, well, you gave me a big directory. I'm not going to waste my time doing this. I'm going to only find out how many files are directly in this directory. And for all the subdirectories, I'm going to go back to the master and say, you take care of it. And that's all the slave does. And the master says, oh, I told you to go explore and you give me more directories? No problem. I'll find other slaves to do it. And it's going to just distribute it. There are several different ways to handle the masters and slave. I'm going to just write one kind of ad hoc solution here. Don't take this as the solution. And of course, any design takes a lot more effort to really structure it. But let's kind of explore a quick example how we would do this. So I'm going to first of all take an actor system, and I'm going to create an actor of. And in this case, I'm going to create a new props. We'll call it as a file collector, for lack of better words. So we'll call it file collector. And that's the class I want to create to begin with. And once I create this file collector, I'll call this as file collector. So file collector. And we'll tell the file collector to go collect files. So we'll say file collector dot tell, and I'm going to tell him the sample path to go look for. Fair enough? So it says go explore this and for me and tell me. So we're done over here. Let's go to the file collector itself. So I go to the file collector. Here's the class I've created. And in this class, I'm going to say, this, of course, extends from untyped actor. So we'll bring in the untyped actor. And of course, I've got to implement this method on receive right there. And what am I going to do in the on receive method? Well, I'm going to first of all take a path, take a message rather. So what am I going to do with the message given to me? The message given to me, I'm going to first of all say in this case, I'm going to put a variable here. What's the variable name? I'm going to say private int, we'll call it count. Now I want you to think about this for a minute. What about this count? Would you agree that this count is isolated mutable? Fair enough to say that? Yeah, because no two threads will ever get to this variable at the same time. It's isolated mutable. Similarly, I'm going to create a private over here int. We'll call it pending. And I want to create a list of slaves. So we'll call it actor ref. And we will call it as file explorers and equal to new array list of those as well. So we'll just create this list of files for now. So this is the file explorers, and we'll say actor ref here for a minute. There we go. That's all I need so far at this point. If you really want to call it private, you could do this too, but it doesn't matter. Nobody's going to see this directly anyways. All right. What's the first step? I'm going to say if the message you gave me is instance of a string, because I'm getting a string reference, what am I going to do now? Well, I've got to go explore more files, isn't it? So this is going to be very simple. I'm going to first say pending is ++, because you told me to go explore a file. Oh, before we do that, pardon me, my kind of mind is multi-threaded, as you can see here. It jumps around. I'm going to create a start over here, and the start essentially is going to be, in this case, time, so system.nanotime. Let's just note the time when we started all of this. So this is going to be a start. Make that a long, okay, fine. So, great. Now that I've said pending is that, what am I going to do? I'm going to say the slave here. So actor ref slave equals, we will get it from the file explorer dot, and we'll remove it. So I got the first object out of it, and I'm going to say a slave dot tell, and I'm going to give him the path itself that I received message. So this master is very clever. He doesn't do any real work, right? So he just sends it to the slave and says, you do the work, right? So this master will make a good manager one day in companies, right? So simply sends other job to the other things to do. Once I send the message, I'm going to simply say file explorer dot, and I'm going to add this back as a slave so I can have more jobs for it next time. There are other better ways to implement it. I'm just putting together a crude and clunky example real quick. Okay, great. Else, what do I do? If it is not a message of that type, what do I do? I'm going to assume it is a message of type integer, by the way. So I'm going to say if message is an instance of integer, so integer over here, and what do I want to do at this time? Well, in that case, what I would like to do is say count plus equals to integer of message. So I'm going to just add it to the message, and I'm going to decrement the pending because we did receive back a message. And then, of course, if pending is equal to 0 at this time, we are done, right? So if it is equal to 0, I'm going to say in this case, so how do I terminate this particular call? Well, of course, to terminate this call, by the way, I'm going to send the current object over here. So we'll come back to that in a second, right? I'll leave that there unattended. So pending, what do? I want to terminate this call. So first of all, let me just output, in this case, the count. And then we will also output the time taken. So we'll say time taken. And what's the time taken, by the way? Time taken is going to be, we'll just print out over here, system.nanotime minus the start time divide by 1.0 E9. Okay, great so far. And of course, it's time for us to go to the context over here. So get context. And once I get the context, I'm going to get the system, and then I'm going to shut down the system itself. Yeah, that's fine. So back over here, I'm going to get the context of where I'm running. So get self, and then send the self itself as to the message. So far, so good, but that requires a couple of more things. I need the explorers, right? Where do I get that from? Well, it turns out there is an interesting message called pre-start I can use. And a pre-start allows me to set up a few things before this gets started. So in here, I'm going to say iterate over, let's say 100 times over here. So we'll call it 100. And what do I want to do? You can configure this, by the way you want to configure it. So 100 times. And in this case, I'm going to simply say actor system. So, so this is going to be get context, get system. So system, and in this case we'll say actor off, and new prop, and this is going to be a bunch of actors. We'll call it the file explorer dot class, which we don't have yet. We'll come back to it. And I create a slave. We'll call it a slave. And then now that I have a slave object, I'll say file explorer dot add, and I'll add the slave to it. So far so good. Assuming I did not miss anything, we are done with this part. Now I have to implement the slave itself. So to implement the slave, what am I going to do? So let's go ahead and say create a class. This class, of course, is going to be extends from untyped actor one more time. Great. And in this case, I'm going to go ahead and implement the onReceive method. Now, what am I going to do here? So string path equals the string message. Again, a lot of error checking, all that you have to do. But you know, well, I don't do error checks on Saturdays, so you know you can do that later on, right? Fair enough. So we have this message that we've received, and what am I going to do with this message? Well, I got to go explore the files. So I'm going to say file equals new file path. I'm going to get the path information from this, and of course in here I'm going to say if file dot, so I need a count. So count equals 0. And if file dot list files is not equal to 0, right? So if it is not equal to 0, I got to go explore it. Not equal to null, rather. I got to go explore it, so null. If it is done, what do? I simply want to go to the sender, right? So get context dot get sender, and to the sender I tell the count, right? Because I'm the slave, I finish my work, I tell the master, here you go, here's the count that I found out. But in the meantime, what am I going to do? In the meantime, I'm going to say for a file child in file.list files, and this case, of course, I'm going to say, as I go through it, if child is a file, then I'm going to simply say count plus plus, else, what should I do? That's correct. Get sender, and then dot, tell the sender child dot get path, and say, you go do the work now. Because I don't want to hold up, I can tell the master to distribute the work across other slaves and be done with it. Now that we are done with this, it is time for us to see if this is going to take us anywhere at all. Let's go back over here to the sample. I think all of that is lined up fairly well. Let's see if this is going to work. So run the code, and we still have the same path we used before, except that we are using multiple threads at this point. So run this. How much time did it take the last time, by the way? No, oh, you know what? Closing this is not a good idea. About 100 seconds. That's correct. It took about 100 seconds. So let's run this and see what it does now, this time. I hope it's a little bit faster than 100 seconds, isn't it? So what did we do? Assuming I wrote this all correct, right? Proper testing is needed. But assuming I did not forget to coordinate things properly, we probably have to come back and check if it doesn't terminate in a few seconds to see. But we basically said, I created an actor, told the actor that this is a sample file I want to work with, and within the file collector, we received the message here, and if the message was a string, I incremented the pending, and I told this child actor to go tell the message to it, and added it back to my list of actors to work with. And then, of course, if the message instance was an integer, I increased the count I received, decrement the pending. The pending is 0, of course. We celebrate here saying we got the result back, and then display the result, and then the system, I shut it down. In the Explorer itself, I'm saying once I receive the message, I want to go ahead and look for all the files. If it is a child file is a file itself, I'll increase the count. Otherwise, I'll send it back to the sender itself to tell him what to do. And then, of course, back here, we are telling him the result. So do you see any things I forgot? Any logic error I made? So, was there error? In main, you're saying? File collector, what did I do wrong? All right. In the file explorer, you're saying? Ah. In the collector. Okay. Let's go to the collector. All right. What did I do wrong here? Right. So I remove it first because basically I have a list of slaves. And I'm obviously this is not a very efficient code. But I want to send a message to a slave, but I don't want to keep sending the message to the same slave over and over. Yeah, the reason is just I could have maintained an index, right? And I could have said, you're the first guy, then the second guy, then the third guy. I could have done it that way. Instead, I said, I removed this guy, I send a message to him, and I put him back in the end of the list, not in the beginning of the list. Yeah? So it goes to the end of the list, not the beginning. All right, so not sure if I had any other logical error. It shouldn't take this long, obviously, to run through. So, oh, there it is. So a little longer than what I expected. But there is one issue here you have to be careful about. There is one problem that you have to keep in mind. This is a very difficult example because when you are dealing with the file system, there is an enormous amount of caching that happens. So the time becomes fairly unpredictable. If you don't run it for a while, it'll take a little longer. If you run it a few times, it'll take a lot less. So it's very difficult to know what the real time is. Last time it was about 100 seconds, but you have to keep in mind that if I run it a few times, the timing will go down. So this time it may actually get less. It depends on it. But I've tried this example obviously before, and I go anywhere from, if it's 100 seconds, it can get back to about 20 seconds or 30 seconds, depending on how you're dealing with it. So obviously I have to go back and look at why it took a little bit more time. But be careful with anytime you deal with the file system, it can get a little unpredictable because it does caching. Never run a program once and say that's the time. You got to run it several times and average things out. And especially the first few runs you want to ignore because you're trying to traverse through this file all over, and that can take a lot of time in the beginning. But once it caches, it can run much faster. But obviously in this case, it's taking a lot longer than it normally takes on my machine, when I did have a machine that actually worked, that is, right? So, but you can download the example from my website later on and play with it on your own machine to see how it is implemented. So clearly the output time here is not representative of what you should see, but obviously I'm not sure what's going on this machine to know the reason for it. Anyway, any questions or comments on this, please? I don't have SSD on my machine. No, I don't. Yeah. I actually barely have a hard drive that works right now on my machine, but no, it doesn't. But it does just quite a bit of caching along the way. So right there, you can see the time already is less this time, but like I pointed out earlier, the times are pretty interesting, how the disk access would be. So to really get a good measure of this, what you need to do is to run the sequential and the concurrent right away, and then see how the difference is. And then run it several times within a few minutes to get a feel for it. All right, any other questions or comments? Yep. Right, so the question is, hey, you're using instance of, are there any better approaches? This is a bit ironic, right? So let me spend a minute on that, talk about that. It's a bit ironic because Scala is statically typed, Java is statically typed, so you would expect a little bit more type information to be available. So there are two answers. The short answer is, it's unfortunate. And the long answer is, it depends. So the short answer is, in the case of Scala and Java, you have type checking, but the message could be any message. It's just bytes coming through the wire, right? So when you receive a message, you don't have a clue what this object type is. So once you have an object on your hand, how do you dispatch it to various methods? Unfortunately, both Scala and Java, you have polymorphism, but polymorphism requires the method signature to be the same between the base and the derived. So the short answer in Java and Scala is, you cannot really avoid this much. However, Groovy has an interesting concept called multi-methods. Groovy has it, Clojure has it. Multi-methods is polymorphism on steroids. And in other words, in polymorphism, the method that's called is based on the type of the target object on which you call the method. In multi-methods, the method you call is based on the type of the target object and the type of the parameters coming in. So in this case, you can actually have 3 or 4 methods with the same name but different input parameters, and when you call a method with just an object, it will know which of these methods it should call based on the runtime type. So this is purely a concept available with multi-methods. And so as a result, in Jeepers, Jeepers is a concurrency library for Groovy written in Java, and in Jeepers, you would write what is called a special type of an actor, and there you would write different on-receive methods with different types, and it would go to them based on the type information. But we don't have multi-methods in Scala unless we find other techniques to work with it. Sorry, go ahead, please. So the answer was, we could do this in Java using parameter overloading. See, this is one thing I really love about Java programmers. They have relentless hope, right? And you're right to have that kind of hope, but it doesn't work. And the reason it won't work is because polymorphism is what is available, not multi-methods. But there are other tricks you could use, by the way. Like you can say, in computer programming, you can solve almost any problem by using one more level of indirection, right? So you could hide this under the covers and say, I'm going to take this call, check for the type in a lower level, and dispatch a call. You can always come up with other funky ideas to solve the problem, but inherently the language itself and the tool itself doesn't solve it. We may have to go through another layer. Oh, yeah, you are absolutely correct. So your point well taken. The reason why this is not a big issue, I really like what you just said. The reason why this is not a big issue in Scala is the way it would look like Scala in Scala is like this. So if you were writing this in Scala, by the way, you would write something like message match, and then you would write case, whatever, right? In this case, I'm going to say count integer, and then you would do the processing for it. The code for it will go here, and then you would say case a path string, and you would write the code for it. So in other words, in Scala, you have this nice pattern matching syntax. Thanks for bringing that up. And as a result, it doesn't smell so bad anymore like it does in the case of Java. So you can see the ceremony aspect again kicking in. Pattern matching is another favorite feature that I have in Scala, that I like in Scala. And absolutely, you're absolutely right. Thanks for pointing that out. So that is the way it's going to look like. So it really seems a little at odds in Java than it really is. This is where the idiomatic things make a difference. They didn't feel any pain doing this because they wrote this in Scala, but when we start using this in Java, we kind of feel a little pain. That's very natural. Yep, please. So the question is, how about getting the results synchronously in main? There are two answers to that. The first answer is, you can try to set up a little local actor here and say, I want to wait on that message, but I would highly recommend not to do that. When I was writing the programming concurrency on the JVM machine, I had shown, this was an older version of Akka, I had shown an example of how you can actually wait and get notification back. And when I sent the book for review to Jonas, the author of Akka, he kind of warned me and said, don't show this example, it's a bad idea to do it. And my first reaction was, well, you have the feature in the language, why shouldn't I show it? And then I thought to myself, here's an idea. He obviously is recommending me not to do this. I should pay attention to it. So why don't I come up with two examples, one where I show the blocking, and one where I make it completely asynchronous. And I told myself that asynchronous code is going to be a lot more difficult than the synchronous version. Obviously, it's better. And when I wrote it, by the way, I was shocked, because the asynchronous version was much superior and much better, and so I actually removed the other one from my book eventually. So it appears strange because we are not used to it, but you need to really think along the lines of that everything is asynchronous, and you want messages to propagate other messages which do the work and get it done than having main to sit and block.
Yeah, but how about integration with other frameworks? For example, containers with the web where you need to wait this request, hold on this request, and
so the question is, what about other situations where there's a servlet and you have to wait for a response to get the response back? The answer is extremely simple, one that many of us may not like. Remember how we learned about objects in matter of hours? And it's almost taken us a lifetime to really design well with objects. Same thing with actors. We can quickly learn actors, but it takes a lot more effort to design with actors. One of the fundamental flaws I see with web development today is we haven't even exploited continuations fairly well. If we have continuations, what happens? You send a request, it sends a response, you go back, you start where you left and move on. And see if you can design a web applications where you don't have to block and wait. And instead you say, so we have to rethink, basically that's what I'm saying, right? So if you're saying, this is how I do things, and I want to fit it into it, it's going to get very clunky. But you say, hey, look what I have on my hand, how differently can I design with this and make things better? You will find a solution to it, right? Yeah, so rethink your design, and you will eventually find a better way to solve these problems. Do I get to sit as well? No, just kidding, please. So definitely a great help. So you need some rest. So take it. All right. So we looked at these actors. I want to show you one more thing, and I'm a little reluctant actually. I show it to you, but it is just to kind of entertain a little thought as to what else we could do with this. So, and then we'll talk about limitations after that. Great. So I want to show you a little bit, another example. Let's write a simple sequential code before we go further with this. Let's say for a minute, I have a collector I'm going to work with. So I'm going to say use collector, and we're going to collect some junk. So collector, use collector, and I'm going to send a collector to this. So I'm going to say a new collector implementation to this. We'll see what this does in just a second. So I'm going to send this over to this particular method call. Now, what is this collector implementation? What this use collector? We'll see in just a minute. So I'm going to say use collector. So I'm going to create a function for this, a method for this, if you will. So let's go ahead and create let's actually start with this first. So let's create a collector class. That's good enough. And I'm going to leave this for a minute. We'll come back and implement more things into this. And I'm going to also go ahead and implement, in this case, let's go ahead and implement this method that I'm working with right here. So this is the use collector method. So what am I going to do in this use collector method? I'm going to take a collector interface that I'm going to work with. And what am I going to do with this collector interface? Let's go ahead and implement this interface. So this is purely a regular Java interface, as you can see. Nothing really special about this. Great. I'm going to do 3 operations on this. I'm going to say collector dot buy, and I'm going to buy 1,000 junk items. I'm going to say collector dot sell. I'm going to sell 500 junk items, and I'm going to output collector dot get quantity, right? So I want to print out how many quantities I have when I'm done with it. Look at this innocent code. 42, 46 doesn't know a whole deal about what we're dealing with. So here is the buy method. I say quantity over here. While we are here, let's create a sell method, and that's going to be a quantity as well. And then finally, I'm going to write get quantity. That's going to tell me how many items I have. Great. So let's move on to this and see how we're going to use this. So what about this collector implementation? Obviously, I need to implement this interface. So we'll say implements, and in this case, the collector, right? So great. And the 3 methods I'm interested in implementing right there, and I'm going to simply say int quantity is this, and the buy is going to just increase the quantity. So we will simply say here that quantity is plus equals quantity, and in this case, of course, we'll simply say this is going to be quantity is minus equals quantity, and finally in here, we'll just return the quantity, right? So very simple code, as you can see. Now, I wrote the collector implementation. I wrote the collector itself. Very simple. Let's run this, and first of all, and just see how this is going to work. Now, the point really in this case is I want to see what threads run this and take note of it. It's at 500, not a big deal. But let's go to the implementation here. And in the buy method, let's output a thread, and I'll say thread.current thread. And I'm going to do this in the buy method, in the sell method, and in the get quantity method. And then, of course, back in the main, I'm going to output the main thread information itself. So we will say main, and then we will just implement, say, thread.current thread, right? So this is good so far. So let's go ahead and run this little example. And it should be no surprise, all of them run in the main thread. So right there, it said main 5, and all that main, and then, of course, 500. Great. But let's think about this a little differently. Let's comment this call out for a minute. I'm not going to change any of the other code I wrote so far. But what I'm going to do this time is I'm going to call use collector, and I'm going to send a collector to him. But what is this collector, by the way? So I'm going to say actor system dot create, and I got access to an actor system. And now I'm going to say typed actor. So I'm going to bring in the typed actor dot actor get, and I'm going to give him the actor system. And I'm going to call in here a little method called actor of, typed actor of, new typed property, and we'll come back and fix this in a second. And I'm going to store this into a collector. Now, what is this collector, by the way? The collector, I'm going to store it. Oops, that didn't go very well. There we go. So this is the collector, but what is this collector? It's going to be collector interface. Now, notice I'm creating a typed actor. And what is the type actor going to have? Excuse me. In here, I have collector implementation, and I'm going to specify collector dot class and collector implementation dot class. So, in other words, what I asked him to do is, he's complaining about what? So, in this case, cannot resolve symbol. This is the collector, and this is the collector implementation. We'll figure out in a minute. So essentially what I told this system was to go create me a so-called a typed actor. But notice what I'm doing to the typed actor. To the typed actor, I'm saying, go ahead and bring in the actor, but wrap the actor for me within a layer of abstraction of an actor. I'm not changing my interface. I'm not changing my class at all, right? I've not made any changes to those in this code at all. So I kept them exactly the same. However, I told them that I really want you to wrap this around in this particular case. That's what I'm saying, right? So this is the interface, and this is the class. So this is the typed actor, typed properties. So we'll find out what the error is in a second. So what does this do, by the way? This is a bit strange, but it creates a proxy for you in front of your object, and you are making a method call to this object. Notice over here, you're calling by and you're calling sell. But the by actually doesn't go on the implementation. The by goes on the proxy. And the proxy says, I'm going to take your call to by and translate that into an asynchronous message. And then it takes the call to sell and translates that into an asynchronous message. On the other hand, remember how getQuantity is not a void method. It's got a return type int. So that becomes a synchronous call. So in this case, it's going to make a call, and it's going to block until that request comes back. But in this case, it automatically implements a timeout. So if my method is going to take a lot of time to respond back, I may timeout and fail, and that's a runtime exception I would have to deal with. Maybe we can put a timeout and play with it if you want to. We can take a look at it. So that is really what's happening in this case. So let's go back and help this guy to deal with the error that he is giving us. So we'll find out what he is unhappy with. So in this case, of course, I've got to give him two parameters. One is the implementation, and then, of course, I got to give him the interface that he's interested in. So collector.class and collector implementation.class are the two values I need to send. And obviously, I don't know what he's complaining about. He says cannot resolve constructor, which takes those two parameters. But obviously, those are the two classes I need to send to this. One is for the collector and one for the collector class. Over here, you're saying. So the first one should be implementation. The second one should be the interface, by the way. Over here at all? All right. So, but only one parameter then. All right. So. The collector is, what are you saying? Sorry, say that again. All right, so this is, let's try this one more time. So this is the typed actor I want to create. So I'm going to say typed actor off. So he needs as parameter a typed properties. So we'll say here, new typed properties. And the typed properties requires a collector implementation. That's what I'm creating the instance of. And I have to give him two parameters in this case. Actually, in this case, it says this API, this library says 1. And in this case, I'm going to give him the, so this should be, if that is the case, this should be the interface logically, and this should be the collector implementation that I want to wrap dot class. Assuming that I have a constructor that, What was that? Oh, yes. Well, yeah, because it's no, not really. You don't need to extend the typed actor. That's not necessary. So obviously, there's a mismatch between the version of the Akka that I'm using here and the one that I'm used to on my machine. But the point really is that at this point, it would create an instance and wrap it. I got to see why this is giving us an error. But the idea really is, let's see if we can understand this error actually in this case. What does it say? So typed actor and covering this. Yeah, that's good. So what does this guy want here? So this says, give me a new so right there is the one that extends object. And then that's a property. So typically, I would give a class name in that regard when I use this. And then I have a reference. Implementation in both. No. So there's actually another option this guy takes. He takes the type property here, but he also takes an actor reference over there. So I could tie him to an actor, but I don't want to tie an actor in this case. And I have a string name as a second property. So I want to use the new type props. That's what I want to use. This is what I'm used to giving to this guy. And this, of course, requires the type. So it's an object in this case. So this is going to be collector implementation. Do what now? Yes. Yeah, he's still not happy with it for some reason. It says it cannot resolve the constructor. That is strange. The class path. I don't believe I need to bring in any. Oh, you know what? Let's see if there's any other libraries I need to bring in. I'm not sure. Usually I have these set up on my machine to bring in the proper jar files. Order of dependency of what? I'm not sure what that means. No, I don't know. All right, so you kind of get the point about what we're trying to do here. So the point is we are trying to get a interface, and then once you get the interface, you can pass it down here. Yep. So well, it could be a package problem. It could very well be. Let's see if that helps us. So let's go back here real quick. That's usually it's a good idea to put them in packages. Let's see if that is true. So worth looking at it. That's a good thought, by the way. I've had problems with packages quite a few times. So that should be, oops, do refactor. So that should be enough at this point, I think. And that is brought in. Let's see if that helps in any way. So it's still complaining at this point. Same error, though. So right there, it says it wants a class collector implementation. So yeah. Anyway, I would have to kind of dig through and see what the error here is and try to resolve it. So once you do, you want to pass that down right here. But the idea is that this would be an asynchronous call, this would become an asynchronous call, and this would become a synchronous call. Now, while this looks a little appealing, this also is pretty scary in my mind. And the reason why it's scary is, without any clear notice, this code suddenly becomes concurrent. And going from sequential to concurrency requires a few other things we have to deal with. For one, when you're running this sequentially, you know that in this case, the buy is complete before you do the sell, and the sell is complete before you do the get quantity. However, when you're doing this asynchronously, there's no guarantee of ordering of these methods. So it is possible that the buy and the sell may execute actually in different order. And as a result, you got to make sure that things are being done properly in terms of the correctness of the code itself. That is something you need to be very careful with. So we looked at actors, we looked at what they do. One of the things they provide, of course, is they provide the ability to do isolated mutability. And isolated mutability is very effective, but actor-based concurrency has some benefits and disadvantages, some limitations. So let's talk about the pros and cons of it. Now, the nice thing about actors is, if you have a task that needs to be running, you can use the isolation on these tasks. And as a result, what happens is, you are basically saying, you go handle this, and when you're done with it, go ahead and finish your work. And if you have mutability to deal with, keep it isolated. Do not let multiple threads interfere with it. So there's a nice clarity in the design itself. When would you use this? You would use this when you have a certain task that you have. A system is task-based, or you want to compose the system into groups of tasks, and you want to distribute this across multiple thread pool. This becomes fairly useful. You are completely avoiding synchronization when you use this. Now, obviously, one of the things you need to be careful with is the message that you pass between actors must be immutable. That is the small part you got to be careful with. If the message you are passing between threads, between actors is mutable, bad things can happen if you start changing them in actors. So that kind of purity you have to make sure. But there are some serious limitations also to actors if you're not very careful in keeping these in mind. One of those limitations is, notice how the actors work through the system. Everything goes to the message queue, and the message queue is really, the actor receives a message from the message queue and processes it. Now, this is great when you want to avoid synchronization issues. But the problem is this. What if you have frequent writers in your system? That's perfect, right? Because the writers line up and say, can I write now, can I write now, can I write now? And writers have concurrency issues, and this says, I beautifully solve it. Great. What if your system has very frequent readers and somewhat less frequent writers? Now we are in trouble. Why? Because every reader has to line up as well, right? Readers are punished. And if you are standing in a line, hey, can I have a quick question, please? No, get back in line, right? So readers are punished, but I'm not changing anything. No, get back in line. So readers have to line up, and so it really says, I'm going to channel the concurrency through, so readers and writers have to line up in the case of actors. In the case of STM, software transactional memory we talked about, readers are utmost priority, right? Readers never block. Any reader instantaneously gets what it wants. The writers are punished. Well, punishment is probably a severe word. Writers have to coordinate. Readers never have to coordinate. Readers get the topmost priority there. In the case of actors, both the writers and the readers have to fall in line and coordinate. And so this is not very effective if you have enormous number of readers and only a few writers. Now, of course, you could say, is there a way to design around it? And the answer is yes. You could probably put immutable objects out and have threads use it, find out that at any given time when things change, they can go back and refill the cache. Whatever that you want to do, you probably can take care of other things, but that is one limitation you have to be careful with. So if you want to think about it this way, this is kind of like you have a printer, and you have a printer pool, and a printer takes a job from a printer pool and prints it, and you don't want your printer to print one of your page and one of another person's page and go back and forth, and then when you pick up this document, it's all completely trashed up with a lot of things in it, right? So an ideal model, something like a printer model, you want the printer to only print one document at a time, and of course you want other printers to take jobs and print it. So if you want that kind of dispatching, this can work really well. So you have a nice model, noted, thank you. So you have a nice model where you basically are going through the process of distributing the request across services. This will work really well. But if you think about the printer model, notice what you have. You have really a continuous write stream. The reads are very infrequent to a printer. Maybe at times you want to know remotely if there are papers still on the printer, but those are infrequent reads, and writes are very frequent. So that kind of model can fit really well into this particular category. So the limitations are there, but if you are going to use it for the right purpose, where you have really a lot of write jobs and coordination to do, actors can be really effective to do that. So that is something to think about. But the bottom line is this: whether you use STM or whether you use actors, the goal is to really go away from the synchronize and suffer model. You know, a question you may ask is, you know, Java has had libraries over the years. They have improved it several times, right? Java 1 had threading. Java 5 had a significant upgrade of multi-threading API. You had concurrent collections added to it. You got the executor services added to it. So enormous improvements, certainly. However, if you look at Java 6, not a whole lot, but Java 7 had improvements also, and you have the ability to more effectively use the pool of threads under the hood. So you may ask, well, with all these improvements, should I not be coding at the JDK level? Well, if you're doing simple things, certainly you could do that. But if you're doing fairly complex things, it becomes very error-prone to do it. So the way I look at it is this. I see the JDK concurrency library as the assembly language for concurrent programming. In other words, STM uses the underlying JDK concurrency library. Actor uses the underlying JDK concurrency library. All of these tools use the JDK concurrency library. They're all built on it. But you don't want to build on it. You want somebody whose full-time effort is to build concurrency API, right? So that's why I want to see the JDK concurrency library as the assembly language of concurrent programming. And how many of you in this room code assembly every day? A few probably, right? There's always this one guy in the room, right? With the purple shirt, right? But most of us don't. And the point really is that we don't want to be coding at the JDK level as well. And of course, every time you write code, you use libraries, there are assembly code being executed, and people like him write it all day long for us, right? And let them continue to do that. So view the JDK library as assembly language of concurrent programming, and do no synchronization code, and that makes our life a lot easier. So you don't have to fight the problem and say, is this really working or not? And you can rely on much better solution. And once again, I cannot thank my friend here enough. Really appreciate your help. I wouldn't have done this without you. Thank you very much. Appreciate it. Thanks.